Hey everybody, let's talk about proportionality. I want to try and review all the things that we've talked about this week and use this as a way for you to study. So let's take a look at our first table here. And let's say that in the story, somebody's selling candy bars and somebody's earning money for selling those candy bars. And what we're going to do is fill this table with proportional data. Okay? So a data is going to be a collection of numbers that go together, right? So for example, if two candy bars cost $3, we can say that if it's proportional, that four candy bars would make $6. We're just saying we sold twice as many candy bars, we earned twice as much money. This is one way that we could fill this table with proportionate data, right? I could double it again and say 8 candy bars would give us, well, twice as much money, or $12. And that's one way of filling out proportional data, but it doesn't, it's really simplistic, right? It really only works if we're doubling the money, or maybe I could just count by twos. 2 more would earn $3 more. But when we run into questions like this, like how much would it cost for, or how much money would I earn for, excuse me, I don't want to do that, would I earn for 7 candy bars, we can't use that doubling trick, and we have to be a little more creative. One of the best ways to move beyond this simple strategy of doubling is to use something called the unit rate. All right, the unit rate. And the unit rate is how much you would, well, in this story, it would be how much money you would make for 1 candy bar. The unit rate is what we see when we find 1 in the x column. You know, when 1 equals x, then y will be our unit rate. So let's just use the simple trick here to take half the candy bars that we know about. If we sold 2 candy bars for $3, 1 candy bar would be $1.50, or 1 5/10. So that is in fact our unit rate. That's one way of finding it. And then with that, right, if we know the unit rate is 1 5/10, we can use that to find any number of candy bars, or how much money we'd earn for any number of candy bars. So I would just say something like this. If I earned $1 at 50 cents, or $1.50 for 1 candy bar, then I would multiply that by 7, right? That would be 7 candy bars. And I would multiply the money I earn also by 7, right? So that would be $10.50, or $10.50. Right? So we basically made this fraction equivalent to this fraction. And since they're not really fractions, they're ratios, we say that they are proportionate to each other. Okay? So the unit rate, pretty brilliant. That'll help us with lots of things. Now, there's another place that we can find that unit rate. If this data is proportional, that unit rate will show up as a multiplier in each of these numbers. If all of these numbers are in a proportionate relationship, that unit rate should show up in each of these. That's 1 5/10. So we can just simply go back and check, right? 4 times 1 5/10 equals 6, that's true. 8 times 1 5/10 equals 12, that's true. And we just saw that 7 times 1 5/10 equals 10.5. So we see that this multiplier works for each of these, or we can say that it constantly works, and we call that the constant of proportionality. So our constant of proportionality is 1.5. That is the same as our unit rate. Right? That is the same as our unit rate. So those two terms are sort of interchangeable. Right? We could say when x is 1, or when I sell 1 candy bar, it will cost the unit rate. It'll cost 1.5. We'll also see that 1 5/10 in here. All right. Later on, we're going to see how to check for that, to see if things are proportional. But right now, let's look at graphing this. These are x, y values. So I'm going to take you see how there's the x column and the y column. I'm going to take those and graph them to a coordinate plane. Graph the x values to the x axes and the y values to the y axes. And let's see what happens. So our first one, we'll just say 1 and 1.5. And the next one was 2, 3. So we'll put another dot right there. And the next one was 4, 6. So we'll put a dot right there. And the next one was 8, 12. 8, 12. Oh, way up here. 8 is right there. And the last one, 7, 10.5. So it backed up a little bit here. 7, 10.5 is right there. All right, right there. And when we look at all these points, and I connect them, what I'm going to see is that they make a straight line. And that's one clue that we're looking at proportional data here. The other clue is that the straight line passes through the origin. Okay, right there. The origin is 0.00. Now that makes sense because in the story, if I sold 0 candy bars, I would probably earn $0. And so a set of proportionate data will always kind of pass through that point. All right, let's look at some other examples. All right, why don't we start out this time and check and see if this data is proportionate? There's 2 ways to check, and you can use these ways as arguments, right? If you're asked to explain how you know something is proportionate, you can use either of these arguments. All right, let's start with the graph again. We're going to graph this point right here, 3, 1. Put it right there. We'll graph the next point, 6, 2. 6, 2 is right there. The next point is 9, 3. That's x first, y second, and 12, 4. 12, 4 is right there. Now, this definitely appears to be a straight line, and that's our first clue. Our second clue is to see if it goes through the origin. And sure enough, it looks like it does. Right? There's our origin right there. So this definitely looks like it is going to be proportionate. 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 So I forgot we checked those 2. So our graph definitely tells us that it's proportionate. It goes through the origin, and it is a straight line. I mean, there is really only one kind of line that is straight. So there it is, right? Those are our 2 checks. Let's look in the table. How can we check? Well, we mentioned earlier that if they have the same constant of proportionality, the same multiplier, then we would have a proportionate relationship. So let's see. How can I find out what this multiplier would be? 3 times what equals 1? Well, you probably know that that's a division problem, right? 3 times what number would equal 1? So we're going to take 1 and divide it by 3. 1 divided by 3. And that's 1/3, right? So that multiplier is 1/3. Now, oddly enough, that's our formula for finding k, right? If you take the y value and divide it by x, you will get the k value. Actually, it's not odd at all. I shouldn't have used that term. So in this case, it looks like k is 1/3, but we don't know if it's constant yet. Let's check some others. Right? Let me write this a little smaller. 1/3. All right, so let's take 2 and divide it by 6. Well, we can see if we do the division, we'll end up with this fraction, but let's just simplify it. It turns out to be 1/3 also. 2 divided by 6 is 1/3. Okay, that's our multiplier. What's 1/3 of 9? Yep, it's 3. That works. What's 1/3 of 12? Yep, it's 4. That works. So it looks like 1/3 is our constant of proportionality. There it is, 1/3. You can also look for it in the unit rate. Right? I'm going to keep going here, but here's another example. Right? So we know that it's proportionate because there's a constant of proportionality. We know that it's a straight line that goes through the origin. That's right. And we can look at our unit rate. If we bought not 3, but only 1 candy bar, then I would pay 1/3 as much money. 1/3 of 1 is 1/3. There's our unit rate. 1/3 matches our constant of proportionality. So there it is. This is definitely a proportionate relationship. All right, let's look at a counterexample. So you know we can see one that's not proportionate. All right, I'm going to graph these real quick. 2, 3, right there. 4, 5, 4, 5. Kind of looks proportionate so far. It's making a straight line. 8, 9. Right there. And 12, 10. 12, 10. Looks like it's right there. All right, this turns out, I would making a big mess here. I would go back and double check that I graph these correctly, but this definitely looks like it's not a straight line. And it also looks like it's not going through the origin, right? When I've kind of highlighted these points, it looks like it's not going through the origin. So this looks like it's not proportionate. Not proportionate. Sorry, it's a little scribbled here. So let's go back and just double check, right? Let me give you another example of why not. I'm going to look for my unit rate. Let's see what K is. So I'm going to pretend if I sold 1 candy bar, that's half as much as 2, that I would earn half as much as 3. I would earn half as much money. So it looks like my unit rate is 1.5, right? Unit rate. I've got to really slow down here and write more clearly. The unit rate equals 1 5/10. Let's see if that's the multiplier here. 4 times 1.5 should be 6. That is not right. 8 times 1.5 should be 12. That is not right. So 12 times 1.5 should be 18. That is not right. So it looks like 1.5 is not our constant multiplier. It looks like there is no constant multiplier. So again, it's not proportionate. So let's see what your arguments are. Not a straight line. Doesn't pass through the origin. No constant multiplier. The unit rate is 1.5, but that doesn't show up constantly throughout the table. So all of those reasons will help you argue whether some data is in a proportionate relationship or not in a proportionate relationship. Okay, I hope this helps. I hope this gives you the information you need to go on and do great things.